Another one is, this is called split range control. The split range controller. Here, only one measurement, two manipulated variables. That is called split range controller. This is the reactor. The reactor pressure has to be controlled. Pressure inside the reactor has to be controlled. Suppose you want to control the pressure, means you can adjust the feed flow rate. Feed flow rate you can adjust. But you reduced to minimum level. Let us assume you reduce to minimum level. Then also pressure exceeds. What we can do is we can open the outlet valve. We can open more the outlet valve so that pressure will not exceed the maximum limit. That's why there are two manipulated variables. One is V1, another one is V2. Both are valves. If this opens, the pressure will decrease. If this closes, the pressure will decrease. Because the feed is decreasing, that's why the pressure will decrease. So this valve, this valve is for increase in controller output, this valve will close. Therefore, this is air to close type. As controller output increases, this will close. This has to open as controller output increases. That's why this is air to open type. This valve is air to open type. But this will work for the range. Total range is what? The controller output is 3 to 15 psi. Total range is 3 to 15 psi. This valve is calibrated for 3 to 9 psi. 3 to 9 psi. 3 to 9 psi, V2 will work. 3 to 9 psi, V2 will work. 9 to 15 psi, this will work. So this is V1 is completely open. Initially, completely open, because for 3 to 15 psi, 3 to 9 psi, completely open. For 9 to 15 psi, this side, for 3 to 9 psi, it opens completely open. Yes, completely open. This is air to open. That's why if it exceeds 9 psi, it will be completely open. This is 3 to 9 psi. That's why if it is V1 is working for 9 to 15 psi. That's why up to 3 to 9 psi, it is completely open. This is completely open for 3 to 9 psi. 9 to 15 psi, this is completely open. Now let us see the how it works. Let us assume that initially it is at 9 psi. The controller output is 9 psi. Both are completely open. It is at nominal operating point. Suppose the pressure exceeds beyond the safe level. The pressure exceeds. What will happen? This is completely open after 9 psi. You cannot do anything. You cannot open beyond 100%. That's why it is completely open. Outlet valve V2 is completely open. But we can close V1. We can reduce the feed flow rate. That's why from 9 to 15 psi, this starts closing. This V1 starts closing. The V1 starts closing. You can see the characteristics of the valve. The other side, the right-hand side characteristic valve. From 9 to 15 psi, the V1 starts closing. Suppose the pressure falls below the nominal value. The pressure falls below nominal value. that is below 9 psi. Below 9 psi means that this is completely open. This is completely open. Say now 6 psi. 6 psi means what will happen? This is completely open. Even maximum feed flow rate is given, the pressure is not built up. So to build the pressure, what happens? 6 psi, the outlet valve is closed partially. V2 is closed partially. That's why the pressure will be developed inside. That is called a split range controller. Split range controller. In that case, this inlet valve opens for 9 to 15 psi, and outlet valve works for 3 to 9 psi. This is air to open. This is air to close. This way we can operate. This way we can operate. That is called split range controller. This valve is available in the lab. If you give 3 to 15 psi, you can see this operation. You can see this operation. One of the valves will be open from 3 to 9 psi. After that, one of the valves will start closing. On the other hand, for 9 to 15 psi, one valve will start closing and the other will completely open. That you can see in the lab. That is available. Split range controller, split range valve is available in the lab. Another split range controller need not be only two. Need not be only two. Here, 3 to 15 psi is divided into two parts. That is 3 to 9 in the previous case, and 9 to 15. Only two cases. Two valves are there in the previous case. It may be increased to 3 also. If you separate this into 3, this span has to be divided into 3 parts. 6, then 6 to 9, 9 to 12, then 12 to 15. Like that, you can separate into this is for V1, this is for V2, this is for V3, and this is for V4. So here, this is a steam header. Steam header means steam will be collected from many boilers. Let us have 4 boilers. Boiler 1, this is boiler 2, boiler 3, and boiler 4. Let us assume. Boiler 1 will be start opening from 3 to 6 psi. After 6 psi, it will be completely open. It is completely open. Let us assume. This will work for 6 to 9 psi. So this will work after 9 because the depends upon the demand here. Demand here, the pressure will drop here. As pressure drops here, boiler 1 is completely open, but pressure is not sufficient. That's why boiler 2 starts open from 6 to 9. Boiler 2 starts from 6 to 9. That is also completely open. The output signal from the controller is 9 psi. It's not sufficient. The pressure inside the header is not sufficient. That's why the third boiler, boiler 3, starts opening from 9 to 12 psi. Again, it's not sufficient, means the fourth one will start opening from 12 to 15 psi. Only 4. Suppose you are having 8, means 2 will work for 3 to 6. Another 2 will work for 6 to 9. Another 2 will work for 9 to 12. And another 2 will work for 12 to 15, like that. Suppose you are having 12. So 3, 3, 3 will work for each range. Like that, you can do. Or you can select, suppose you are having 6 such boilers, you can group this into 3, 3. This will work for 3 to 9 psi, and this will work for 9 to 15 psi. Like that, you can put. So anyhow, the output of the controller is split into many spans. So each valve will work for a particular span. In this case, all are air to open. All are air to open. In the previous case, what we have seen, the first one is air to close, and V1 is air to close, and V2 is air to open. Here all are air to open. All are air to open. So here the pressure transmitter transmits the power available in the steam line. Based on that, the pressure controller will give control output from 3 to 15 psi, but the valve will work according to the input range or output range of the controller. The next one is, this is all about multi-loop controller. Here, multi-loop controller may be either single measurement, many manipulation, like this single manipulation, single measurement, many manipulation. This split range also here, single measurement, many manipulation, actioneering, many measurement, but only one manipulation, override. Here, two measurements, but only one manipulation. Here also, two measurements, one manipulation. So these are all examples for multi-loop controller.